Hello, and today we're going to look at perpendicular bisectors. Now the clue to what a perpendicular bisector is in the name. Okay, we're going to split this up and look at the two words separately. So perpendicular means at right angle, and bisector means to cut in half. Bisect means to cut in half. Okay, so here's an example of a perpendicular bisector of AB. So that means it's the perpendicular bisector from the coordinates AB, which is the line AB. So the perpendicular bisector itself is a line, there it is there. And it's a line that comes at right angles to the line AB, but it's also right in the middle of AB, passes through its midpoint. Okay. Perpendicular bisectors of any sides, of the sides of any triangle, are concurrent. So if you had a perpendicular bisector coming from there, and from there, they would all meet at a point and you would say they are concurrent. They have the same point of intersection. This point is called the circumcenter of the triangle. Circumcenter comes from the perpendicular bisector. You really have to remember that fact. It may be something that can come up in a question, and it's more that you're familiar with that rather than remembering it as such. Okay, so find the equation of the perpendicular bisector of AB, and here are our coordinates. So drawn it as a triangle, but it doesn't even have to be part of a triangle. It could just be a random line. But the important thing is that the perpendicular bisector is the line that comes from the middle of AB, and it's also at right angles. So you have to be able to visualize what a perpendicular bisector is to be able to work out what information you need to find the equation of the perpendicular bisector. So we have our coordinates AB, they're given there. We have to think, what am I going to have to do? Use some common sense here. So I'm going to have to get a coordinate there, which will be the middle of AB. So I'm going to have to find the midpoint. And then I'm going to have to get the other thing that I need for the equation of the line, which is the gradient. So to get the gradient, I'm going to get the gradient of AB and then use my perpendicular gradient to get the gradient of the perpendicular bisector that I need. And then once I've got that coordinate there and the gradient of that line, I can then use the y minus b equals m bracket x minus a formula to find the equation of the perpendicular bisector. So we're going to find the gradient of AB. That will help us to find the gradient of the perpendicular line. We'll find the point on the perpendicular line, which is the centre of A and B. And then we'll find the equation of the perpendicular line. Okay, so here we have our coordinates AB. So the first thing we'll do is find the gradient of AB. Okay, so 7 minus 3 over minus 4 minus 2. 4 over minus 6. Now you have to be careful here because we're going to be left with a fraction. What you've got to watch is that you don't leave the negative on the bottom of the fraction. You recognise that that's a positive divided by a negative. So we want the negative to be overall just in front of the fraction to show that you know it's an overall negative fraction now. If you leave the negative hovering beside the number in the bottom, it will look as though you don't know the very simple fact that a positive divided by a negative is an overall negative. It will look as though you don't know what to do with it. And obviously we have the 4 and the 6 that we have to simplify as well. So look how the negatives become an overall negative, and the 4 and the 6 have simplified to 2/3. So we've got a negative 2/3 as our gradient. So remember how you then find the perpendicular gradient. You turn the fraction upside down and you change the sign. So that's why it's important that you look to see what the overall fraction is. It's an overall negative. An overall negative will become an overall positive when you do the perpendicular gradient. A common error that people make is they make that negative, that positive, and keep it still as an overall negative. So that's an overall negative and it's going to become an overall positive. And obviously we turn the 2 and the 3 upside down. So the gradient of the perpendicular is going to be 3 over 2, and it's positive 3 over 2. Instead of negative 2/3, it's now positive 3 over 2. Okay, and that comes from that rule there. Gradients multiplied together give you -1. We've done all that before. Okay, so now the midpoint of the coordinates A and B. So we add our two x's together and we half them. And then to find the middle y part of it, we add the two y's together and we half them. So we add the two x's together, we half them, and we add the two y's together. So we're going to add the 2 and the -4. We'll half it, and then add the 3 and the 7, and we'll half that too. Okay, so 2 plus -4 is 2. Take away 4, which is -2 over 2. And then 3 plus 7, which is 10 over 2. Now, if you ever forget what you do to find the middle of two coordinates, pick two random numbers like 3 and 5 that you know the middle of. You know the middle of 3 and 5 is 4. Think with the numbers 3 and 5. What would I do to those numbers to get 4? Because a common error is that sometimes people subtract the two numbers by accident. Okay, and if you have the number 3 and 5, you know you have to add them together to get 8 and half that to get your 4. You wouldn't subtract them. It wouldn't give you anywhere near 4 to do that. So if you're ever unsure of a formula, check with simple numbers to help you to remember. Okay, so we have to simplify these here. So -2 over 2 is -1, and 10 over 2 is your 5. So we've now got a coordinate on the perpendicular bisector, and we've now got our gradient. Now, it's really important to make sure things stand out and you don't accidentally go back and use the wrong gradient. So you might want to underline things as you're going through or rewrite them again, but be very careful. This is the type of question that if you get distracted in the middle of it, you can end up mixing up the numbers that you're using and using the wrong numbers. So be careful. So there I've summarised it. We've now got the coordinate, okay, which is -1, 5, and the gradient, which is 3 over 2, and we're now going to find the equation of that line. So we can see now we're not using any of these coordinates, and we've obviously got our gradient worked out as well. So we go back to the y minus b equals m bracket x minus a formula. That's your a, that's your b, that's your m. Y minus 5 equals 3 over 2, x minus -1, what's your double negatives? So we'll sort that part out there with the double negatives, and then we'll take the 2 over to the left and make it a times. Okay, so now we're going to take the 2 over to the left, multiply each of these by that 2, and now that 3 becomes a whole number, 3 in front of the bracket. Okay, so we're just going to multiply out that bracket on the right, then take the -10 over to the right to make it a plus 10, and that leaves us with 2y equals 3x plus 13. Now remember what I said about rearranging it, okay? You might see in the back of the book a slightly different rearrangement, and if you see, for example, that the 2y is brought in there with the negative, you think, well, if I just brought that 2y in there and made it, that would become a negative, and then they would all be on the same side and everything else would be equal to 0. So make sure you're able to compare and see that these are the same, because if you leave your answer like that, that's fine. A marker would be able to tell the difference between that and that. But if you're looking up the answers and you see that, and you see your answer is that, I want you to know that they are the same. And if you're not sure, you have to get a teacher to check. So in this case, you should send in a photo of any answers you're not sure about and ask your teacher to confirm that they are correct. Okay, and you can do that through your Google Classroom. That would also be the same thing as well. Everything on the left-hand side. That one technically is not the general equation of the straight line, although everything's on the same side. Remember, xy number equals 0, and you should always put it to the side that makes the x positive to get it correctly into the general equation. But if it doesn't ask specifically for any format, that one would be fine, that one would be fine, and that one would be fine, and lots of different variations of it. Okay, so we're now on to exercise 1i, and we have our selection of questions there. As always, remember to ask your teacher for help either in person or through your Google Classroom. And good luck and take care.